Welcome to week 16 in geometry. We are quickly approaching the end of the semester. We are about 1 week out from the last day of the semester. So the last day of the semester, remember, is December 22nd. The last day to submit late work is December 21st. So I will mention that a few times just to make sure that we aren't missing any important dates. So if you're working on getting caught up, keep working. And if you're working on getting a grade to where you want it to be, make sure you're sending in redos for Unit 4 only. So I'm only accepting redos for the current unit. And since we're on Unit 4, for Unit 4 only. And this is the last unit. This is the last unit in Semester 1. So just to let you know that. So we are continuing to study about right triangles this week. We are going to be looking at trigonometry this week, which is probably new for a lot of you. And it is important that you have a scientific calculator this week, and even when you're watching this recording, so that you can practice with using some trig functions and make sure that you're in the right mode. So at this time, I do want you to make sure that not only you have your math notebook, that you also have access to a scientific calculator. And a scientific calculator is going to have sine, cosine, and tangent written on it, and it's going to be written as SIN for sine. So look on your calculator for sine, cosine, and tangent on your calculator. And if you do not have those, you can use an online scientific calculator, and here's the website to access an online scientific calculator. So if you don't have a scientific calculator that has the sine, cosine, and tangent buttons on it, that's okay. Go ahead and use this, this website. So you can type it into a browser and have a second browser open. But before we get to looking at trigonometry, let's do a review here. So look at this warm-up question. I've got a right triangle, and then I've drawn in an altitude and created 2 more right triangles, which are all similar to one another. So there's essentially 3 triangles in here. There's ABD, there's CBD, and then there's ABC. There is some given information. The length of AB is 12. The length of AC, so all the way from here to here, is 24. And, oops, it's not letting me write that in here, so I'll write it up here. It's 24. And then the length of, what do we need to find? The length of AD. So we need to find the length from A to D, so I'll put X in there. So think about a proportion that you can set up, and I want you to click pause and try this on your own. And then when you're ready to check your work with mine, go ahead and click play. All right, so I have the hypotenuse of this leg over the short leg of this triangle. So this triangle here, ABD, I've got labeled the hypotenuse and then the short leg. So that's what I'm going to use to set up my proportion. I'm going to compare the hypotenuse over the short leg. And I'm going to set up a proportion. I also, when I'm looking at this other triangle, triangle ABC, I also have the hypotenuse and the short leg labeled. So I can go ahead and use that as a blueprint to set up my proportion. So if I do the hypotenuse of my smaller triangle, I'm going to have 12 over the short leg, which is X. And then my bigger triangle, triangle ABC, my hypotenuse is from here to here. And then the short leg is this leg AB. So let's go ahead and put in the hypotenuse length, which is 24, over the short leg length, which is 12. And then, of course, we're going to use cross multiplication. I kind of covered up my number there. That's 12, remember? So we're going to have 12 times 12 and set it equal to 24 times x, or 24x. 144 is what we get when we take 12 times 12. So I'm going to continue up here. I'm running out of space down there. So 144 equals 24x. And then to get to x, I'm going to divide each side by 24. So x is going to equal 144 divided by 24. And I get 6. So the length from A to D is going to be equal to 6. So since x represents the length from A to D, we can say that AD equals 6. And that is my final answer. So check your work with mine. Just keeping those proportions in mind and how we can use proportions to solve for missing side lengths when we have an altitude drawn into a right triangle. So I'm going to continue on. All right, so this week we are finishing up Unit 4. And these will be the last assignments, last tasks, last concepts you are learning about in Semester 1. So we are going to start this week with being introduced to trig ratios, sine, cosine, and tangent. And then you're going to learn how to apply those trig ratios so that you can solve for missing side lengths of right triangles. And then we're going to wrap up Unit 4 by taking the Unit 4 test. Those are the last tasks for the semester. So once you are done with this week's folder, you are done for the semester. We're 1 week out from the end of the semester. I think I actually said 2.5. I'm not sure why I said that, but the correct timeline here is that we're 1 week out from the last day of the semester. So the last day of the semester is December 22nd. So if you don't already have that marked down somewhere, mark that down, write it down, put it on a sticky tab, put it on your computer. And then another really important date is December 22nd. That is next Monday. That is the last day I will accept any late work or redos from Unit 4. So only redos from Unit 4. And then it's the last day to submit any missing work on December 21st. All right, so here we go. Trig ratios. So make sure you've got your notebook out and you're ready to take good notes because this is all should be brand new to most of you. So there's going to be two important words you're going to be using a lot when you work with trig ratios. Those words are adjacent and opposite. So what do they mean in terms of trigonometry? So let's pick an angle. I'm going to pick angle A here. So I just marked in this angle A, and we're going to use angle A as a reference point. We're going to pretend we're hanging out here. That's a person, a stick figure. We're hanging out at angle A. So what do these two words mean in relation to this angle? So adjacent means right next to something, right? So that means that really we've got two angles here that are adjacent, right, to this angle. But really only one of them we're going to be using as adjacent when we are talking about right triangles. So which one would be the adjacent one? It's going to be angle A. This side is what I meant to say. I'm looking at angle A. Side B is going to be the adjacent angle, and I'm about to explain right now. This leg right here, C, is always the hypotenuse. Remember, the leg opposite of our right angle is the hypotenuse. So this leg here is always going to be the hypotenuse. The hypotenuse cannot also be the adjacent leg. It can only be one thing. It's always the hypotenuse. So the adjacent leg to angle A would only be this side B right here. Remember, this one is only the hypotenuse. So adjacent means right next to. So if we change colors and our reference angle, let's say we're going to use B as our reference angle, we'll never use the right angle as a reference angle, so keep that in mind. The other angle over here, if we're hanging out at angle B now, and we use this as our reference angle, which side would be the adjacent leg? Well, again, remember this side C is a hypotenuse, and it can only act as a hypotenuse. So that means that this leg here is right next to angle A, or angle B. I meant to say angle B. So this would be the adjacent angle. What about opposite? What about opposite? So let's stick with our reference point of angle B. So the opposite side to angle B is going to be over here. So this would be the opposite side, side B would be the opposite side. It's opposite to angle B. If we go back to our reference point of angle A, the side opposite of angle A would be right over here. So we would say that this is the opposite side. So color is really important here. In reference to angle A, I've labeled everything in reference to angle A in red. So the opposite side to angle A is going to be this side A right here. The adjacent angle would be side B, and then remember the hypotenuse is always just the hypotenuse. Same with the purple colors. So it's important we know these because when we start talking about trig ratios, we're going to use these words. We're going to use adjacent and opposite when we set up our trig ratios. So again, what is trigonometry? Trigonometry, again, is the study between angles and sides of triangles, and it allows us to find measurements of missing sides and angles of right triangles when using known information and ratios that we know exist. Trigonometry involves triangle measurement and the ratio of lengths of sides called trigonomic ratios. So let's take a look at what those three trig ratios are. So we've got three trig ratios. They are sine, cosine, and tangent. So sine is the ratio between a angle. So we're going to find an angle, and then comparing to that angle, or in reference to that angle, we're going to set up a ratio comparing the opposite side over the hypotenuse. And that is why we just reviewed on the previous slide where these things are located. So if we choose this as our reference angle, then the opposite side would be right here, opposite side over the hypotenuse. That is the sine ratio. The cosine is if we choose an angle, a reference angle, it's going to be the adjacent side to that angle, whichever one we choose, compare over the hypotenuse. So we can choose this side as our reference angle, this one, but let's say we choose this one. It's a right angle. So we want to compare the adjacent side. Remember, the adjacent can only be the adjacent. The hypotenuse cannot be the adjacent as well. And you should be starting to see why, because we've got really three things: the opposite, the adjacent, and the hypotenuse. And then the tangent is a ratio. When we compare the tangent, it's the opposite side in reference to an angle over the adjacent side. So if we choose a reference, it doesn't matter, we'll choose this one, it's a right angle. So the opposite would be over here, and then the adjacent. So you might be wondering, how can I remember this? Well, there's a mnemonic we can use to remember these three ratios, and that is so, ka, toa. So if you look here, so represents sine. So we've got sine equals opposite over hypotenuse. There's the so. We use the first three letters to remember sine. So is sine opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Then we've got ka to remember the cosine ratio, which is going to be cosine equals adjacent over hypotenuse. So this is cosine. And then we've got tangent, toa, which is opposite over adjacent. So that's going to help you, that little mnemonic, remember what the ratios are. So write that down in your math notebook right now. So katoa, to remember sine, cosine, and tangent. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so now let's use these. Let's set up some of our trig ratios and make sure that we're good to go here. So we've got a right triangle. We've got triangle PQR, and we've got all of our sides labeled. So if we want to find the sine of angle Q, let's set up, and for sine, we can abbreviate that as SIN, and that's what it's going to look like on your calculator as well. So sine, we can abbreviate as SIN. So remember sine, what is sine? So it's going to be the opposite side over the, that's H, over the hypotenuse. All right, and we want to find the sine of angle Q. I'm going to sneak in Q in there. So Q. So I'm going to put a little arc here to let us know that this is our reference angle. And we want to find the opposite over the hypotenuse. So which leg is opposite to angle Q? Well, this leg here, PQ, is going to be the adjacent leg. This leg here is opposite, and this one is our PQ, is the hypotenuse. So the opposite leg is right here. That's 12. So I'm going to start over and say sine Q equals 12. And then what is the hypotenuse? Hypotenuse is always opposite of our right angle, so leg RQ is going to be the hypotenuse, which is 13. So there's our ratio. Sine Q is 12 over 13. I'm going to scribble this out, and now we need to find the tangent of angle R. So angle R is right here. And what is tangent? So remember, tangent is opposite TOA, opposite over adjacent, TOA. So if we want to find the tangent of R, which side is opposite of R? 5. And then which side is the adjacent? Remember, 13 cannot be adjacent because 13 is the hypotenuse. So that leaves that side RP is going to be the adjacent side, which is 12. So now, why don't you go ahead and try to do the last one. See if you can do it on your own. So cosine, remember cosine ka is adjacent over hypotenuse. So go ahead and see if you can come up with the cosine. And we can abbreviate cosine as COS. We can abbreviate tangent as TAN. I forgot to say that. So go ahead now and see if you can set up the cosine R. So we're using R as our reference point again. See if you can find the cosine ratio of angle R. So if you want to click pause and try it on your own. So the adjacent side is 12. It can't be 13, even though it's right next to it, because 13 is X as the hypotenuse. And then the side opposite would be 5. This side here is our opposite. Or I'm sorry, we're doing not opposite. I meant to say we are doing the hypotenuse, whoops, which is 13. So it's 12 over 13. Adjacent over hypotenuse is 12 over 13. All righty, so moving on to the next slide. So if you need more time, go ahead and click pause. All right, so time to grab your scientific calculator or go to that online website so that we can practice using our calculator and make sure that we're in the correct mode, especially if you're using like a TI-83 or TI-84. We need to be in the correct mode. We need to be in degrees mode. So in order to make sure if you've got the calculator, the TI, the Texas Instruments, let's make sure we're in the right mode. So if you look in the upper right-hand corner of your calculator, you should see a key that says second, and to the right of that, you should see a key that says mode. So click on that key that says mode, and then if you scroll down to the third line, you're going to see it says radian and degrees, and we want to make sure that degrees is highlighted. we want to make sure that degrees is highlighted. So just scroll down with your arrows and then scroll over to degrees and hit enter, and it will now be in the correct mode, which is degrees. So now, if you're using the online site, you shouldn't have to do that. Don't worry about that. So now clear out of that and type in sine 30 and hit enter. And what do you get? You should get 0.5. So again, if you're not getting 0.5, that probably means you're not in the correct mode. So now go ahead and press cosine, which we represent with COS, and go to 2 decimal places and let me know what you get. You should get 0.97. And then we'll do tangent 50. And you should get 1.19 if we round 2 decimal places. So just wanted to make sure that your mode is in the correct mode so that when you grab your calculator this week, if you're using a Texas Instruments, a TI 83 or 84, any of the TIs, you have to be in the right mode. If you're not in the right mode, most likely you're not going to have these right, or you won't have these correct answers. So this is a checkpoint to make sure that you're in the correct mode. All right, moving on. All right, so let's now put it all together and use a trig ratio to find an unknown side. That's the whole point of why we use trig ratios, is to help us find unknown side lengths or unknown angles in right triangles. So we've got a diagram here where we're given an angle measurement, and we want to find, we also have this side length given here, AC, and we want to find the length of A to B. So we want, add that in here, we want to find AB. So from here to here. I'm going to put an X there. So we're given a reference angle, right? We always need a reference angle in order to set up one of our trig ratios. So first we need to decide which trig ratio we should use. So if this is our reference point, which 2 sides are we dealing with? This side over here, BC, is useless to us. There's no length on it, and it's not one we're trying to find the length of. So the 2 sides that we are going to find useful are side AB and side AC. So which 2 sides are those in reference to angle 40, angle A? So we've got the hypotenuse and we've got the adjacent. So when we've got the adjacent and the hypotenuse, which trig ratio uses those? And I always think, okay, we've got SO and we've got CA and we've got TOA. So which one uses the adjacent and the hypotenuse? CA. So we're going to use cosine. So to solve this, we would say the cosine of 40, we always want to put the angle measurement after the cosine, after the tangent, or after the sine. So we always say cosine angle measurement, or tangent angle measurement, whatever trig function we're using, equals the adjacent side is 100 and the hypotenuse is x. So we've got one unknown that we're trying to find. So how do we solve for x now? We're just going to use some algebra. So it's hard to find an unknown when it's on the denominator. So what I'm going to do is I'm going to go ahead and multiply both sides by x. And that way the x cancels out on the left side of the equation, right? It's gone. And now we're left with cosine, x times cosine 40 equals 100. And to solve for x, we're going to divide each side by cosine 40. We're going to use algebra, right? So we need to grab a calculator now, and then the cosines will cancel out on the left. And to solve for x, we're simply going to grab a calculator, and we're going to type in 100 divided by cosine 40. And then we'll round to 2 decimal places. And when you've done this correctly, you should get 130.54. So what I did was I just typed in my calculator 100, and then I hit divided by. I typed in the cosine key 140, and then I hit enter. And you should get 130.54, and we're dealing with yards. So the length of A to B is 130.54 yards. So that is how we can use trig ratios to find missing sides. So I'm going to go on to the next slide. So if you need more time, go ahead and click pause. So we just looked at an example where we used a trig ratio to find an unknown side length. So we used a reference angle. We were given an angle and we were given a side, and we needed to find another side. So we were able to set up our trig ratio using that given angle measurement and one of our sides to set up a ratio and then solve for the unknown part of that ratio. Where now you can also use a trig ratio to find an unknown angle. So look at this example right here. This triangle, we have two given sides and an unknown angle. So we can use a trig ratio to find that unknown angle. So I'm not going to get into detail here because this recording's getting a little long and I want to wrap it up, but I did want to point out that when you are determining the missing angle measurement of a right triangle, you're going to be using something called an inverse trig function. So what is an inverse trig function? So let's back up a little bit. So if we grabbed our calculator, we plug in sine 30, we would find that the calculator would give us the answer as 0.5. So we can work backwards as well here. So if we know that working backwards, we can conclude if we know the sine of an angle, an acute angle is 0.5, then we know the measurement would have to be, of that angle, it has to be 30 degrees. So when we use our trig ratios to find an unknown angle measurement, so only for unknown angle measurements, we're going to use the inverse trig function. We're going to work backwards. We're going to go from our ratio. So if we had a ratio, this could be like 1/2, right? Because 1/2 equals 0.5. So if we were given a ratio of 1/2, that would be like the sine, the opposite over for sine, hypotenuse, would be the 1/2. We can go opposite and find the given angle measurement if we have two parts of our ratio. We can work backwards to find the angle measurement by using the inverse trig function on your calculator. So if you look at your scientific calculator, you can see above the sine, cosine, and tangent key, it says sine to the -1, or cosine to the -1, or tangent to the -1. So these are the inverse functions that you're going to be using to find the correct angle measurement. So you only use the inverse trig functions when you're finding a missing angle measurement. So let's see that really quick there. So if we wanted to practice on our calculator, we're going to do that right now. Let's use our calculator to find angle measurements using our inverse functions. So to find the cosine, the inverse cosine of 0.5, you're going to hit the second key to access that cosine to the -1. So you're going to hit second cosine, and then on your calculator you should see the cosine to the -1, and then plug in 0.5. And when you do that, you should get 60 degrees. So again, this is checking to make sure your calculators are set up correctly. Then go ahead and try to find the inverse sine of 0.52. And when you do that, you should get 31.33. So we're going to find a missing angle measurement now, and then we're going to wrap up this recording. So back to this triangle that should look familiar. We want to find the measurement of angle B. So which trig ratio are we going to use? That's our first question. So in reference to angle A, we have the hypotenuse and the adjacent. So remember, if we have SO, CA, and TOA, that means that adjacent hypotenuse, we're going to use the cosine. So we're going to use the inverse of the cosine function to find this angle measurement. So what we're going to have is we're going to have cosine, we don't know the angle, equals the adjacent side, which is 2.5 over 2.5, the adjacent side over the hypotenuse, which is 4.0. And then in order to solve, remember, since we're finding an angle measurement, we have to use the inverse function. So what we're going to do is we're going to grab our calculators, we're going to type in the inverse cosine, and then we're going to type in 2.5 over 4. And what do you get? So second cosine, to get that inverse cosine on your calculator, then type in 2.5 divided by 4. And again, we're going to round to 2 decimal places. I get 51.32 degrees. And that's our final answer. But again, a rule of thumb is when you're finding an unknown angle measurement, you have to use the inverse function key in order to find that missing angle. And that's it. So for the key phrase this week, we looked at how we can use trig ratios to find missing sides and missing angle measurements. But I said that there's a special type of trig function that you use when you are finding a missing angle measurement. And what is that? I'm not looking for sine, cosine, or tangent, but there's a type of all 3 of those that we use when we're finding missing angle measurements. And what is that? And that's it. Have a great rest of your week, and let me know if you need help with anything.